Give you a totally different.
Where are we at? Sorry.
Say if you were just to type in the first, the numbers up top, first step. No. ln 11.2 x1 divided by ln 438. If you were to plug those in the.
Well, of course it does, because that wouldn't do anything.
So it doesn't work for you.
Say again?
That doesn't. I thought the calculator would work that whole problem for you.
No. No. Sorry, buddy. I don't mean to laugh at you. I'm sorry. But the calculator, you can't plug an equation in. Can you? No. Now remember, you could do this. You could put y1 is, got it, 11.2 to the x minus 1. y2 is the other side. Remember this stuff? And then graph it. Zoom 6. Let's see what happens. Look at that. There's one graph. Here comes the other graph. Come on. You can do it, other graph. There you are, other graph. Ooh, they're gross looking. They are gross looking. But it looks like the answer might be somewhere in there. So if I zoom in. Anyway, you guys remember all this. This works for any equation in the universe if I can graph it. So watch it. If I zoom in a lot. This is exciting. All right. There's that one. Look, the outputs are so tiny, it's hugging the zero really tight. And the same thing there. Look at that. It's just crazy. So the answer's in there somewhere. You keep zooming in until you can see it. Are you guys with me on that? Or right now, I should be able to do it. How do I find the intersection of those two? Yeah, go to second trace to get to calculate. Intersect. Put my cursor on the answer, and the answer looks to be in here somewhere. There, the answer is negative 0.658. Wow. Crazy. So you can always check your work for any equation that way, if you have time. Okay. Now that looks horrendous, and there's so many places in here that you can make mistakes, and they're all related to the fact that you're not used to working with something that looks like this. Just remember, this is like the number 7. In fact, one way people do this is right here. This problem's done, right? This problem's done. But like right here, what is ln of 11.2? I don't know. So I could use something like u sub, but I'm going to call it like b. Now again, please, dear God, you don't have to do this, but I want to show you this because this is an option. So what does A mean? ln 438. And what's B mean? Now, why would I ever do that? Because that looks a lot better. Good Lord. That looks a lot better. Some of you guys might say, no, it doesn't, Jeff, because there's A's and B's now, but it looks a lot better than ln of 11 now. Because here I can just do xb minus b equals xa, subtract xb. I mean, that looks a little bit easier. And at the end, so subtract xb, I get negative b equals x times a minus b. Divide by a minus b. Now I can replace b with ln 11.2. A is ln 438. B is ln 11.2. I mean, it makes it easier to work with in the middle. It's like that u sub idea. That looks gross. Let me replace it with something that looks better. And at the end, I'll put them back in. That's an option that's there for you. You don't have to. Okay. What about, let me make sure I talked about all the weirdness. Yeah, okay, cool. I like it. Oh, so here's one little weirdness here. Somebody got what they want from this? Okay. What would you do first on this problem? You could do it, Jeff. Oh, yeah, let's just do this. Everything we've done until now there was no number sitting out front, right? If I do an ln right now, it would sort of suck, because it would be an ln of a product. I just want to attack this guy directly, so get him out of the freaking way. Divide by 50, like, yeah. So now I can attack that exponential thing directly. Become a 3. Yeah, so now you do ln of both sides. So 2x ln 3 divide by ln 3. I like it. You guys doing too much.
How do you get rid of the 2 then?
You're going to divide at the end.
ln 3 on both sides.
Well, don't just divide by ln 3. I think it's what I just said, but divide by everything you want to get rid of.
Oh,
2 ln 3.
okay.
Because what's everything doing here? Multiplying. So division will kill anything you don't want. Yeah. I like it. So x equals ln 5 over twice ln 3. And again, you can plug it in a calculator and get an exact answer. Kick ass.
With the x stuff.
Say again, sorry.
When you divided 2 ln 3. Okay.
Still there. And all the other stuff moved over there. All right.
That's the answer.
Total. I mean, that's the exact answer, and if you plug it in the calculator, you can get the approximate answer. What's ln 5? Now, be careful. Again, you have to say, not tangent, Jeff. ln of 5 divided by parentheses 2 ln 3. So if you have more than one piece on the bottom, you got to put parentheses so it knows the whole damn thing is down there. So here's really cool. Now watch. How do I check that? Well, 50 times 3 to the twice that is supposed to be what? What am I supposed to go on? 50 times 3 to the twice that. I'm supposed to get 250, and I do. Nah. So remember that little A and S button? A and S. That holds the last number on the screen. So that's a real quick way to check your work. I like the look on some of your faces. That's all I can say, Jeff. So it's too bad. I'm going to do more. One more type of equation, and then I want to give a little preview of what's coming in the next chapter. Therefore, that's what I'll do, because I do what I want. Let me see. I know they do this kind of problem, don't they? Let me make sure I'm not showing any too freaky. Do they? Oh, there. Okay. Well, sort of. All right. Just for completeness for myself. Screw it. So what if I had? What does that look like? Isn't the middle one like half the first ones? Doesn't it look like x squared minus x minus 6 equals 0? Isn't that problem easy as freaking hell? I have no problem saying that. If it isn't, then that's a problem with me. So isn't this problem just as easy as freaking hell? If that was x squared, how do you factor? What do you put here? X and x, because that's got 2 of them. So what would you put here? E to the x, because there's 2 of them up there, isn't there? And then you just need numbers that work right. What's the numbers that work for -6 to make -1? Yeah, 3 and 2. Which one's negative? I like it. So there could be some problems like this. It's what we call quadratic in form. It looks like it wants to be a quadratic, and it is, because that is half of this. So I should be able to break that up, and then the middle term is exactly what it's supposed to be. So then e to the x equals 3. You see that? Or e to the x equals, one of those is impossible. One of those is impossible. Let me make that into a question. Yeah, the second one. Because e to the x can't go negative, can it? Because remember, in the back of your brains, you should remember that's what e to the x does. Does it have any negative outputs? That's impossible. Screw it. This one, what do I do to solve it? Oh shit, man, this is a double level problem. It's no big deal. What would I always use? What log? ln. And what's the beautiful thing on this problem? ln of e is gone. So I get x equals ln 3 done.
Wait, repeat that. Wait, how did you eliminate your answer? The negative.
So from this one I got this, right? Is that cool?
Yeah.
And then you take ln of both sides. What's ln of e?
Oh, yeah.
So x equals ln 3. Bam. So it's another kind of equation that can have exponentials in it. Cool, I like it, maybe. So if you couldn't factor this, you could imagine you could use quadratic. I'm not going to do that to you. Quadratic with exponentials gets a little freaky, so, but it's not impossible. If you go to pre-calc, you're definitely going to do that kind of stuff. All right, so a little preview of what's to come. What we're about to get into in this next chapter is looking at what's called conic sections. So what I'm going to do is I'll have preloaded some animations from online, but if you imagine like a cone, you don't even have to imagine it. Let me draw one. Look at that. For me, that's amazing. So here's why it's called conic sections. If I chop this thing straight across the middle, anywhere across the middle, what shape will I get? What will the cross section be in the shape of?
Circle.
Circle. I like it. You with me? Of course, I didn't look like a circle because this is 3D. If I was looking directly down into it, that would be a circle up there, wouldn't it? So any cross section of the cone would look like a circle cut straight across. You with me? So that's why it's called conic sections. Cool. Now, what if I were to cut at a diagonal? What would happen then? What do you think? A circle's got to be perfectly round, perfectly symmetric in all directions. So if I do it at a diagonal, I'm going to get an ellipse. I like it. So this is a circle. This would be an ellipse. They should have... Yes, cool. They got pictures on page 870 if you have your book, so it shows you what's going on. For the other ones, I need kind of like the other half of this thing, really. So now if I chop it, this is not the easiest thing to show on this, but here, good. It's a little difficult to show full 3D, but in here they got a nice computer-generated. Look at that, isn't that beautiful? That blurry shit. Let's see what happens here. Focus. There, focus. Autofocus, you have done me wrong. Oh, it was just zoomed into it. Okay. Is that better?
Yeah.
Can you guys see what's going on there? So if I chop at an angle, but not through, but from one side, do you see? So like a circle and ellipse have to kind of make a complete loop. This one is chopping, but not going to the other side of the cone. It's just going straight through. So it's open. So that would be a parabola, because one side of the parabola just keeps opening up. It never comes back to itself. And then the shape that's the weirdest shape that people don't work with, they work with it the least, is a hyperbola, Where'd it go? There it is. So a hyperbola looks like that. And you can see if I chop it straight down, I'm going to get, it looks like a parabola and another parabola, but they're not the same kind of curvature. They're normally a little more extreme curve. And things that move in hyperbolic orbits, like comets. Comets can have parabolic orbits or hyperbolic orbits, right? You guys kind of with me here a little bit? What comet keeps coming back?
Halley's?
Halley's Comet. I love it. So it doesn't have one of those kind of orbits. It has an elliptical orbit. So that's what makes it, lets it come back. But if a comet had a hyperbolic orbit, that means we'd only see it once, ever. And then it would be gone. Bye, comet. Never again. Thanks for not smashing into us. Very nice of you, right? So this conic section stuff has immediate application for orbits of gravitationally controlled bodies, like orbits of the planets and so forth, right? Asteroids is going to hit Earth. Well, shit, if we only could math it up, if we could figure out the equation of motion of this thing, we can see if it's going to intersect with the equation of motion of Earth, and then we can send Bruce Willis and everybody up there. They can do their thing. He's really old now, so we can just blow him up, no problem. Poor yeah, let's kill him. He's done what he's going to do. All right. So that's what we're getting into. So, of course, the next step, I'm making it sound like I'm going to let you go right now, but I'm not. But the next step, obviously, is talking about the equations. So, like, watch this. This is the last thing. This, honestly, is the last thing today. For a circle. How would you describe a circle if you weren't allowed to draw a circle? How would you describe it to somebody?
It's got two outlets for every input.
So, but there's a lot of shapes that's true for.
It's like roundish.
It's like this.
Yeah. So let's pretend the person you're talking to is blind, recently blind.
Let's hear a baseball.
This is becoming a sad problem, but
It's soft.
it looks like a baseball, but they've never seen baseball.
Feel this ball.
It's a blind alien that understands English. So what's true? Give me why is this one this big and not small? Or what is it that controls the size of a circle? The radius. Radius controls the circumference, right? And what is the radius? How would you define the radius?
Half the diameter. Center line.
Don't define something based on something else that we need a definition for.
Something on the outside.
What's the really important part of a circle besides the radius? Because could I have a circle sitting over there? What's different about these two circles besides the radius is a different size? I just gave it away. But the
Area.
what is that point there? What is this? That's the center. Okay, now, given that there is a center of a circle, how would you define the radius?
On the outside of the circle, the center.
Yes, so it's the distance. So now I can define a circle. A circle is the collection of all points. They're the same distance from the center. Think about it. So given a distance, let's say 4, and I say, okay, now collect all the points that are the same distance from the center that are 4 away from the center, you would get a circle. You guys understand what's happening? So it's just like making your compass. You guys ever use the compass? Not this kind of compass, not Jack Sparrow. I'm talking about the compass that opens and it's got the pointy part that you arm people if you give it to them. And you set it to a certain thing, that's setting the radius, and then you turn it, and that's collecting all the points that are that far away from the middle. All right, Jeff, you've made your point there. So tell me this. Now stay with me. What point is this? I love that question. Do you know what point that is? No. But it has 2 parts. Do you know what either part is? No. So what am I going to call the whole point? What am I going to call it? I don't know what either part is. I'm just going to call it XY. Kick ass. And I could have put that point here or there. I would have called it XY, no matter where the hell it is. And what about the radius? Let's let the radius be R, because just to be general. It could be 4, it could be 18, it could be 0.7, whatever. Where's X? That would be here, right? That's X. And what's this? Y. That's amazing. Okay, now, for any point I pick, how must these three things be related? Well, what picture did I just draw? What did I just draw? All right, I understand why somebody said square, maybe rectangle, but triangle. How long is this? Is an X long? And how long is this? Y. So what's true about these? What do they have to follow since they're in a, what kind of a triangle is this?
Right.
Right triangle. Right, so what has to be true?
X squared plus Y squared equals 4 squared.
That is the equation of a circle. Right? We use the definition of a circle. All the points are the same distance from the center. We use that definition, and then we came up with an equation. So if I saw this equation, x squared plus y squared equals 16, what's the radius of that circle?
4.
It's not 16, it's 4. Because it's r squared. So what would you square to get 16? 4. So it's got a radius of 4, and the center is 0, 0. So what would the center of this one be? 1, -3. See all that shit we did before with the h and k was getting us ready for this, because that's going to be true for all these conic sections. I can move their center very easily by just doing this to it. So that these are both circles of radius 4. This is centered at the origin. This one's centered at 1, -3. Does everybody see that? This idea, we've talked about that idea before. Yes, sir.
So you could find more than one circle on a single XY plane.
Totally. Because I can like graph multiple parabolas on a single plane if I wanted to. So I can have several, I can have this circle, and then this one be at 1, -3 would be its center, and then I could draw that circle, right? Cool. All right, so that's just a little baby step into the next section. And if you look in the back of your grade sheet summary that I passed out, we'll get into all those notes, but you can look at them beforehand if you want to. We'll get into that tomorrow. So don't forget, first thing tomorrow is the quiz.
What section is this? What section did we go with?
13.1. Some of it. Yeah.